Welcome to this session of the 2021 Dean Lee Beef and Forage Field Day. I'm Vince Deshotel, County Agent and also Central Region Livestock Agent. The presentation I will present to you today is understanding the basics of soil fertility, related to pasture management and also some crop nutrition issues. One of the most important things we must remember that forages serve as a food source for livestock and other nutritional needs. Some things to know about forages. Forages are an economical feed source for any species of livestock when they exist. Forages are also good for animal health and welfare. Under well-managed forage systems, they build soil health, control erosion, capture carbon from the atmosphere. Forage systems also provide more organic matter than most cultivated cropping systems. And forages are readily converted into protein sources such as milk, meat, and eggs that are so important to our daily diets as a protein source. This next slide concerning soil health is somewhat of a picture of what soil health comprises of. Related to crop inputs, we talk about pesticide use regarding insecticides, herbicides, and some fungicides. We mentioned carbon management in the previous slide. Also equipment use, both positive and negative effects of equipment use related to preparations of lands for either crop production or livestock production. And some of the more important factors, human and animal health. Without good soil health, we have lack of human health and animal health. Crop productivity and efficiency. If soil health is in place, we should have good productive soils. And most importantly, water and air quality. As good stewards of the land, we want to leave it better than we found it for our generations to come. Therefore, one of the top priorities of soil health is soil testing. So the question is, why should we soil test? Soil testing provides a baseline assessment of your soil's fertility levels. It also indicates some unknowns about the soils, such as pH values, available nutrients, levels of nitrogen, phosphorus, potassium, calcium, magnesium, and sodium, or to name a few, and many of the micronutrients not named here on this slide. It also provides us with the soil texture. Soil texture is relative to how much sand, silt, and clay exist in the soils that we're dealing with. Also, suggested fertilizer rates for crop potential and what your intentions are as far as crop production. As we begin to analyze some of the popular fertilizer analysis, we begin with the big three. Nitrogen, phosphorus, and potassium are the three major components in most fertilizer analysis we may experience. So with that being said, in the case of triple 13, there's 13% nitrogen, 13% phosphorus, and 13% potassium, expressed in a percentage by volume. So in the case of the pictures that I have indicated on this slide, of a 32-10-10, there's 32% nitrogen, 10% phosphorus, and 10% potassium in this particular analysis. As we begin analyzing some of the macronutrients found in some common fertilizer blends that we might experience. In the case of nitrogen, in the photo I have to the left is urea, 4600. Nitrogen is considered the backbone for plant wealth and health. It is the most important nutrient, keeping it green. Nitrogen is responsible for production of cell membranes and chlorophyll used in a daily process known as photosynthesis, or producing food and energy charged by sunlight. Nitrogen is also responsible for protein and amino acid production, as we mentioned in our protein sources of milk, meat, and eggs, to name a few. Nitrogen also plays a key role in DNA traits in modern agriculture with gene tracing and sorts. Nitrogen is converted to protein sources through photosynthesis, very important to most diets, whether it be human or animal production. Nitrogen deficiencies in the plant world are often easy to identify to the trained eye. Plants are less vigorous with low growth and low performance. Due to the lack of chlorophyll production, plants have spindly growth, pale in color, pale green or yellow. It is usually associated with lower or older leaves that show first signs of nitrogen deficiencies. In this next slide, I've included a few pictures that clearly indicate some nitrogen deficiencies. On the bottom right-hand corner, commonly seen by the livestock producer, would be some bahia grass that is deficient in nitrogen. Pale green to a yellow color, long spindly leaves that is deficient in production. The upper right-hand picture are two wheat plants, one with adequate amounts of a nitrogen and the one to the right showing signs of dieback or nitrogen deficiency at its lower older leaves. And on the left side is in a field setting where these plants are obviously deficient in nitrogen because of their dieback or yellowing at their lower or older leaves. As we begin to discuss phosphorus in the fertilizer analysis, phosphorus holds the second spot of the big three, often represented as a 004600 or sometimes as a 18460 in some fertilizer analysis. Phosphorus supports the process of photosynthesis as well. It is also responsible for respiration, protein and nucleic acid synthesis within the plant, and nutrients transport through a plant cell wall by storing energy. Some of the more important factors that phosphorus is responsible for is seed production in the plant world. It promotes increased root growth and tillering, offering more yield in some cropping settings. Phosphorus promotes early plant maturity based on the date of planting. It also promotes stalk strength and provides some resistance to root diseases. Some important factors to know about phosphorus in livestock. It's responsible for skeletal structure, bones, teeth, and most body fluids, and some soft tissues. Phosphorus in livestock also plays a role in appetite control and utilizing feed intake and efficiency, and also more importantly in reproduction. Inadequate phosphorus levels in animals often result in lower levels of immunity, increasing the susceptibility to disease and infection, and also subpar reproductive levels. In this next slide, I've included a few photographs of some obvious phosphorus deficiencies. On the left side is a field of wheat in a research setting. The plants show obvious of low growth or low vigor and also no tillering. On the right side are two photographs, one of bahia grass on the top and of corn at the bottom. Commonly seen are these symptoms of browning and purpling color in the early spring with cold, wet soils. Until warmer temperatures arrive, the utilization of phosphorus in the soils are not available to the plant. However, an additional amendment of phosphorus may be needed to correct this situation. And finally, the final number representing the big three, and potassium, often represented in a fertilizer analysis of a 000060. Potassium is the third key nutrient and element utilized in a plant's overall productivity. It is responsible for disease resistance in plants, crop yields and the quality of the product harvested. It is also responsible for adequate levels of potassium and helps protect plants during colder periods or droughty conditions, preventing wilt. Potassium is also responsible during photosynthesis and regulates the opening and closing of the plant's stomata, in turn regulating CO2 uptake. Potassium also regulates a plant's shape, size, and color, and taste when mature. In this next slide, I've included a few photographs indicating some potassium deficiencies. Unlike nitrogen, where the older leaves show the first signs, the younger leaves, in this case with a potassium deficiency, are also associated with tip burn or some leaf margins that are burned back. In this next slide, I've included a photograph with several common symptoms of some nitrogen, phosphorus, and potassium deficiencies, and also some things not to mistake when we talk about diseases and some drought stress, and also some micronutrient deficiencies. As you can see, in the upper left is a healthy plant leaf. The lower is a phosphorus deficiency with the purpling. Magnesium deficiencies are striped within the intervanals. Herbicide injuries are generally splotched or associated with leaf margins. Clearly, the nitrogen deficiency is, as we described previously, tip burn and the midrib. Potassium deficiencies occur on the leaf margins and on the tips. Outside of the big three, we have other macronutrients that play vital roles in a plant's productivity. Sulfur being one of those, often represented as a 21-00-00-24. Sulfur is utilized by plants in making two of the essential amino acids needed to make proteins, in small amounts, generally 8 to 12 pounds per acre annually. Sulfur can also be used to lower high soil pH levels, in many cases in situations as important as phosphorus. Sulfur deficiencies normally occur on low organic matter soils. Deficiencies in sulfur can also be corrected with applications of elemental sulfur and or gypsum. Magnesium, another critical macronutrient found in a fertilizer analysis. Magnesium helps plants to maintain high levels of chlorophyll in leaves to maintain healthy green leaf tissues. It also supports the plant growth and yield regarding forages and crops. Magnesium is also responsible for structural stabilization of plant tissues, transportation of carbohydrates to different growing tissues, including roots, shoots, and reproductive organs, and stress tolerance mechanisms. However, excessive levels of magnesium can have negative impacts on forages and other agronomic crops. The main causes of deficiencies are other nutrients in soils, such as calcium and potassium. This scenario will be considered a nutrient tie-up when magnesium is toxic. This next slide is a picture I found that uniquely displays some of the deficiencies we may often encounter. However, deficiencies may vary from plant to plant and certainly will differ from monocots to dicots. Monocots being your grass family and dicots being your broadleaves, which the only ones we may encounter is some deficiencies related to soybean production, which are often used for forages, and also with some legumes such as some of our clovers. As we near the close of this presentation, if there's one take-home message I need to send to you, it's that plants need a balance of nutrients in the soil to thrive and perform. More importantly, nutrients include magnesium, potassium, and calcium. Some soils readily contain these nutrients. However, those soils that do not cannot acquire them without an addition of some fertilizers. These fertilizers help ensure the proper addition of nutrients in the soil and help maintain a soil acidity, which are all necessary for healthy plants. Each nutrient plays an important role for plant growth, and either an excess or deficiency of any one nutrient can make the difference in plant production and yield. And finally, in closing this presentation, determining the needs for crops and forages should begin with a soil test for macro and micronutrients present in the soil, and also the soil's pH. You should learn your soil's limiting factors and what amendments may be needed based on the soil test. Have your fertilizer needs custom blended based on the soil test, the crop intentions, and the animal needs. Also, whenever possible, utilize products that will last longer in the soil. And remember, never over-apply nutrients that may lead to runoff into streams and water bodies. Reduce soil compaction whenever possible so nutrients will be available for longer periods during growing seasons. And soil health is the goal, achieving the balance of a rich soil, rich in nutrients, and meeting the production levels desired. I hope what I have presented today will help you in your future decision-making processes with forages and crops. My contact information is presented on this slide. If you have any questions about the material presented, please feel free to reach out and contact me, either by email or call me on my office phone at 337-948-0561. Let the Ag Center help you better understand soil fertility in the future moving forward. Thanks for tuning into our program today.